You may see these questions pop up every once in a while, or math problems, where you have a statement like, the sum of 5 consecutive odd numbers is 265. What is the middle number? What's the smallest number? What is the largest number? And maybe even what are all the numbers? You may not have 5 consecutive numbers. You might have 2 or 3. And they may be even or odd, but they're typically integers. And it could be any, random number that the sum is equal to. So we can figure these out pretty easily, especially when they're consecutive. That basically tells us the difference between each number that they're asking for. But what if they're not consecutive? You do have to have a link between the numbers of some sort. So we're going to walk through this particular question by hand, but then we're going to delve into my more favorite way to solve these kind of questions, and that's with matrices.
We can simply take 265 and divide that by 5. And that equals 53. So we know we have 5 numbers. We found the middle number. So let's just say we have A, B, C, D, and E. Our middle number is 53. We know it's 5 consecutive odd numbers, so there's going to be 2 difference between each number, right? So 53 minus 2 is 51. 51 minus 2 is 49. 53 plus 2 is 55. And then 2 more is 57. So our largest number is 57. The middle number is 53. The smallest number is 49. And all of the numbers are 49, 51, 53, 55, and 57.
Now we can do this one more way.
And that's with the matrix. We'll call this matrix A. And then we'll have matrix B. I should have made that the same. And then we'll use matrix C as our result matrix. So matrix C is what we're trying to figure out. And that's going to be A, B, C, D, and E. Now, we know that the sum of our numbers is 265. So for matrix A, we're going to put like a multiplier in between the A, B, C, D, and E, or in front of each of the variables, okay? And then we know that when we add those, so 1A plus 1B plus 1C plus 1D plus 1E equals 265. So row 1 of matrix A is going to be 5 ones. So 1, 2, 3, 4, 5. Now we know that the difference is 2. So matrix B we know that the sum of all of these added together is 265. Now, to come up with the rest of the rows of our matrix, we know that minus A, or you know what? Let's do 1A. So A plus a negative B. So we know B is the next value. We know that this is 2 more. So if we do A minus B, we should get negative 2. So over here we're going to have negative 2 in matrix B. And then matrix A is going to be 1A and a negative 1B. And then if you pretend that we have 0C plus 0D plus 0E, A minus B is negative 2. Now, we can go about this a few different ways. We can continue with the A, or we can move to the B, positive B, and then a negative C. So for this example, I'm going to continue with the positive A, and then we're going to go to a negative C, a negative D, and a negative E. So A plus 0B plus negative C plus 0D plus 0E. So this is 2 less. Now this is going to be 4 less. So negative 4. All right, so we can finish filling in row 2, and then we can fill in row 3 as well. So these are going to be 0C, 0D, 0E. Now for our third row, 1A, 0B, negative 1C, 0D, and 0E. The next is going to be A plus 0B plus 0C plus a negative D plus 0E. So this one's going to be 2, 4, 6. Negative 6. Now if you see the pattern here, negative 2, negative 4, negative 6, the next one's going to be 2 less again, so we can put in a negative 8, and I'll show you how that's found. So our negative 6 is going to be 1A, 0B, 0C, negative 1D, 0E. Now we notice a pattern over here. You can also see a pattern developing over here. So this is going to be 1, 0, 0, 0, negative 1 for E. Down here that would be 1A plus 0B plus 0C plus 0D plus a negative E. Now we're going to jump over to the MG15C, HP15C emulator calculator to find the results of this.
I have the MG15C emulator calculator up and running. Some things to take notice here are in the emulator, I display matrix A through E down here between the entire real and imaginary stack and our memory registers. So what's nice is that we will be able to see which element the pointer is pointing at, and we'll be able to see the result matrix down here without recalling every single element of the matrix. To set the calculator up for matrices, first we can dimension our matrix A and our matrix B. So matrix A in this case is a 5 by 5. So 5, enter, and then F dim A. Then we can press 1, enter. Sorry about that, not enter. We'll rotate that stack down. Just 1. And then what that will do is it'll push the stack, and we'll have our 5 row by 1 column for matrix B. So there's our dimensions of matrix B in the Y and X. Now, F dim B. We can see down here we've got our 5 by 5 matrix A, and then our 5 by 1 matrix B. Now we need to tell the calculator to point at the row 1, column 1 element. So we press F matrix 1, and you can see where our pointer is at here now. We're going to turn on user mode, and then we're ready to start entering our elements. So our first element is A, so 1 in matrix A. Stow A, you can see that's going in 1, 1. See that there. Now it's still in our X, so we can go through and store the entire row. So stow A, stow A, stow A, stow A. Now row 2, column 1 is also a 1, so stow A. Then we have to change sign, stow A. Then we're going back to zeros. So 0, stow A. Now, we can change where our pointer is by using memory registers 1 and 0. So let's go down to row 3, stow 0, and then column 1, stow 1 to move our pointer. This is a 1, so we have that in our X of our stack, so we can hit stow A. And notice when we press stow that we get the matrix descriptor, which is the matrix name, and then followed by the element that we are storing into. And it does the same for recall also. So now we are in row 3, column 2, which is a 0, stow A, and then -1, stow A, and then the remaining values are 0. So we can go back to column 1, and then row 4, make that a 1, stow A, If we want to, we can just go 0 stow A to get through also. So we don't always have to just change the pointer. We can just cycle through. 1, change sign for the -1, stow A. And 0, stow A. 1, stow A. Here we'll change that again. So let's go to column 5. So 5, stow 1. 1, change sign, stow A. Now we've cycled all the way through our matrix. You notice how row 1 is all 1s, column 1 is all 1s, and then you see how our -1 cycles through the elements in that pattern that we saw earlier. Now we can start storing elements into matrix B. So our first element is 265, stow B, and then 2, change sign, stow B. Now I'm just going to do 2 minus to get the -4, stow B, 2 minus, stow B, 2 minus, stow B. Now on the HP calculator, and it's exactly how my emulator works, is we need to recall matrix B. Recall matrix B, and then we're going to recall matrix A, and then we're going to press the divide button to divide the two matrices. Now we have our result matrix and matrix C. I think this is similar to the real HP15C. However, my emulator defaults to matrix C as the result matrix. I want to follow through the other example where we go from A to B and then B to C, C to D, and finally D to E. The first matrix setup referenced A the entire for every other equation or row to fill in the matrix, right? So matrix A, matrix B, matrix C. It's going to give us our A, B, C, D, and E. It's going to be the same basic equation. 1A plus 1B plus 1C plus 1D plus 1E equals 265. Now, because it said every odd number, we know the difference between A and B is 2, B and C is 2, C and D is 2, and then D and E is also 2. So for matrix A, we have 1, 1, 1, 1, 1, and 265. Now,
this first one is going to be the same. So 1 and -1, 0, 0, 0 is -2. But instead of going -2, -4, -6, -8, we're going to keep every one of these at -2. Then our next row is going to be a 0A, 1B, -1C, 0D, and 0E. Now you can already start to see the pattern developing here. So we're going to have 0, 0, 1, -1, 0. Then we're going to have 0, 0, 0, 1, -1. And now we'll jump over to the emulator. Enter these two matrices to solve A, B, C, D, and E.
Okay, I've refreshed the calculator, which is essentially like pressing on while holding the minus key. It resets to the initial state, wipes out all the memory and all the variables and whatnot in the program. So, as I mentioned earlier, we can change that result matrix. So we're going to press F result E. I know I said we're using matrix C in the example. However, here we'll look at matrix E for the result. Now we need to redimension our matrix. So 5 enter gets our rows and columns for the 5x5 matrix. So we'll dimension matrix A. And we see that becomes dimension down here. And last time I pressed enter, but here we only need to press 1. It pushes the stack, so now we have our 5x1 matrix. So we will dimension matrix B. Something else to mention about the emulator and the real HP15C is that it's automatically going to dimension your result matrix. So there's no need to dimension the result matrix. So we're going to set our pointer back to, by pressing F, matrix 1 sets it to row 1, column 1, or the 1, 1 element of the matrix. And we can see that here when we press F, matrix 1. Now we will enter all of the variables of the matrix. So to do that, we're going to turn on user mode. And we have 1 in our stack. Now I'm going to use some shortcut keys here, okay? So I've put all the keyboard keys in the gray on the bottom right. So to save a little bit of time, we have 1 and X, so I'm going to just press S and A for the store into the A, and you'll be able to see the matrix pointer put the variable in the particular element it's pointing at and then cycle through. So 1, stow A, stow A, stow A, stow A, stow A, stow A, change sign is M, stow A, and then because this is probably faster than storing into memory 1 and 0, I'll just press 0, stow A, stow A, stow A, 1. No, that is not correct. This is where this changes. So 0, stow A, 1, stow A, 1, change sign, stow A, 0, stow A, stow A, stow A, stow A, 1, stow A, 1, change sign, stow A, 0, stow A, all right. Now there is our matrix A populated, we will go down to matrix B. So here we have 265 stow B, and then the remaining elements are -2. So 2 change sign stow B, stow B, stow B, stow B. Now we've populated matrix B. So we are ready to recall our matrix matrix descriptors, to the stack. So recall matrix B, recall matrix A, divide. Now notice here how we changed our result matrix to matrix E, and it indeed went to matrix E. Something else to point out is that we have 49, 51, 53, 55, and 57. So there are all of the numbers. The smallest was 49, and the middle was 53, and the highest number was 57, the greatest number. Okay, we will go on to the next question.
I changed the question up to make it a little bit harder this time. The previous question was dealing with consecutive numbers. So what if your numbers aren't consecutive, right? So I came up with a question, or a statement, and then a question. My 4 dogs, Alpha, Bravo, Charlie, and Delta, weigh a total of 265 pounds. I made both of these questions up, and it was just by chance that the sum both came to 265. I don't know how that happened. So Alpha weighs 27 pounds less than Bravo. Charlie weighs 20 pounds less than Delta. Bravo weighs 38 pounds less than Delta. How much does each dog weigh? So we're going to set up another matrix. This one's going to be a 4 by 4. And before we do that, let's set our equation up, right? And I did this on purpose too. Alpha is going to be A, Bravo B, Charlie C, and Delta D. But notice we only have 4 variables here. So we're going to have 4 unknowns. It's going to require 4 equations. With that said, it's going to be a 4 by 4 matrix and then a 4 by 1 matrix. So our equation is going to look like A, or 1A plus 1B plus 1C plus 1D equals 265. Now, we know the difference between some of the dogs. So we'll start to set up our matrices. So matrix A, matrix B, and matrix C. Matrix A is going to look like 1, 1, 1, 1, and 265. Matrix C is going to be our A, B, C, and D. I went too far. Okay. Now, Alpha weighs 27 pounds less than Bravo. So if we start with 1 Alpha and we subtract 1 Bravo, -1 Bravo, we're going to get -27 pounds. Charlie weighs 20 pounds less than Delta. So 1 Charlie Let's finish our row here. 0, 0. Now we have 1 Charlie, -1 Delta is going to be -20 pounds. So to finish our row, 0 and 0. Now our final equation. Bravo weighs 38 pounds less than Delta. So 1 Bravo, -1 Delta is -38. And we'll finish the row 0 and 0. Now we can enter these in the MG15C emulator. Matrix B divided by matrix A will give us matrix C, and those elements will be the weights of each dog.
Let's dimension our matrices. We have the 4x4, so 4, enter, F, dim, A, and then just the 1 to get our 4 row 1 column for matrix B, so F, dim, B. Why don't we set our result to matrix D this time? So we'll do F result D, and then we will set our pointer, so F matrix 1 sets our pointer of our freshly dimensioned matrices. We will turn on user mode, and then we are ready to enter our value. So we already have our 1 in our X register of our stack, so we will go through this fairly quickly. Stow A, stow A, stow A, stow A, stow A, 1, change sign, stow A, 0, stow A, stow A, stow A, stow A, and then 1, stow A, change sign, stow A, 0, stow A, 1, stow A, 0, stow A, 1, change sign, stow A. Now, the matrix has been populated, our matrix A. So let's go through and populate matrix B. So 265, stow B, 27, change sign, stow B, 20, change sign, stow B, and 38, change sign, stow B. Now we are going to recall our matrices to the stack. So recall matrix B, recall matrix A, divide, and matrix D is automatically dimensioned, and then we have the results of the dog weights. Alright, so the first one is 32, 59, 77, and 97. Alpha is 32 pounds. Bravo is 59 pounds. Charlie is 77 pounds. And Delta is 97 pounds. And we will label pounds for all of the elements of the matrix there. And there we have it. That is how we can calculate with different values that aren't consecutive. The next thing that we should do is go through our result matrix and verify that the results follow the parameters that were set in the initial problem statement or question, I suppose. The sum of our 4 elements should be 265 pounds. In order to do that, our matrix pointer is pointing at row 1, column 1. We are going to bring the individual elements of matrix D back onto the stack to sum them together. So we'll press recall D. Our pointer incremented. Recall D. Stack pushes. We get the second element. Recall D. And recall D. Now our stack is filled up, so we will do 1, 2, 3 pluses or additions. 1, 2, 3 to get a sum of 265 pounds. Now, the problem statement also states that alpha weighs 27 pounds less than Bravo. So if we recall Bravo, let's put in 2 stow 0, recall D 59, and then I'm going to cheat and look at these values down here, understanding that the first one is alpha, then Bravo, then Charlie, then Delta. That was the whole point of making these visible, right? So I didn't have to go through every keystroke like recalling 59 there. Or all of them when we sum them together. So alpha weighs 27 pounds less than Bravo. We have the Bravo weight of 59 recalled. We have 2 ways we can do this. We can subtract 27. And we get 32, which is the weight of alpha. So that is correct. Then we say Charlie is 20 pounds less than Delta. So we should be able to do, well, we can see 97 is 20 pounds less than 77. But 97, enter, 77, subtract. Now the way that we did this in the matrix would have been more like 77, enter, 97, change sign, plus, to give us the negative 20 pounds. And then Bravo weighs 38 pounds less than Delta. So if we take 97, 38, subtract, we get 59, which is the weight of Bravo. All right, for those of you who stuck around, this was probably one of the longest videos on record that I have made. I really appreciate it. I'd love it if you liked it and subscribed it. I'm not in it for anything. It's more just a hobby that I do on the side. Thanks for watching. Have a good one.